So the next question gives us a table and we have to find the pattern, and specifically it wants us to find a recursive definition again. So we know recursive definitions have to give a start value. So the only ones that show that are choice 3 and choice 4. I'm just going to draw a line through. So we're going to cross out 1 and 2. Now the question is, are we multiplying by 1.00939 to get from term to term, or are we adding 7? It looks like in the first one, yeah, the adding 7 isn't even close to what's going on. If I look at this pattern, it looks like even in the first one we're not adding anything close. So, but if we try the 1.00939, so we're going to try the first term times the 1.00939, that would give me 7,628. And if we tried 7,628 times the 1.00939, that once again does give me something very close to this answer, so that looks like the best choice. The next one says Kayla needs $30,000 for a down payment on a house she plans to purchase in 8 years. She decides to invest in a savings account which gets 3.5% interest compounded at the end of each year. How much money should Kayla put in the account at the beginning of each year to reach her goal? Assume she makes the same deposit on January 1st each of the 8 years and makes no other deposits or withdrawals throughout the year. Here is the formula we're going to use, where A is the amount of money after T years, D is the number of dollars invested at the beginning of each year, and R is the annual interest rate of the account expressed as a decimal. So this is one of those with a random formula, and we need to plug in the numbers. So we want to have $30,000 at the end. We're trying to save up for the down payment. We have 8 years to do so. We're asking how much to put in at the beginning of each year. And the interest rate on the account is 0.035. So now we're going to plug in the numbers. We have 30,000. That we set equal to D is what we're trying to find. So X over 0.035 times 1 plus 0.035 to the 8th minus 1. So I'm going to type this part into my calculator. And there's a couple different ways I can do this. I'm going to keep it kind of simple here. So that gives us 30,000 equals X over 0.035 times approximately 0.32. That's definitely something you'll want to keep in your calculator. We could combine more and simplify more on the right side, but I'm just going to divide by the 0.32. And if I keep the whole decimal, that should give me approximately 94,000. Trying to find it. 94,694. Once again, keeping the whole decimal. That equals X over 0.035. We're getting a little crowded here. 0.035. So that's an awful 0.035, the same as this 0.035. The next thing I'm going to do, which I'm going to have to just do verbally, is multiply by 0.035 on both sides. So I'm multiplying this side by 0.035. Sorry, I muted myself. So we're multiplying by 0.035 on both sides. I do not have room to write it on the other side, but I'm just going to cross it out, and that's going to give me a final answer of $3,314.30. So that is choice 3. So now we have a recursive formula that has 2 parts to it, kind of like the Fibonacci sequence. So this says the Pell numbers can be defined recursively by this formula. So my first term is 0, my second term is 1, and to get to the next term, I multiply the last term by 2 and add the term that came before it. So we want to find P of 6. So since I have 1 and 2, the next thing I'm going to find is P of 3. So this is 2. If I plug in a 3 for this n, I get P of 2, because 3 minus 1 is 2, plus P of 3 minus 2 is 1. So P of 3 is going to equal 2. P of 2 is 1, so I'm plugging in a 1 for the P of 2. P of 1 is 0, so I'm plugging in a 0 here. So P of 3 is the number 2. Then to get to P of 4, we're going to do 2, and we just want to kind of find that pattern. So I noticed to get P of 3, I take P of 2. So now to get P of 4, I'm going to do 2 times P of 3. So I'm going to bring down this 2, and then I'm going to add P of 1, or P of 2. So we have 2 and 1. Here we're doing 3 and 2. P of 2 is 1. So for this answer, I get 5. P of 5, we're going to do 2 times the term before it. So 2 times 5 plus the term 2 before that. So plus 2. So that gives me 12. And P of 6 is 2 times 12 plus the term that came before that, the 5. So that's going to give me 29, which is choice 4. That's definitely an advanced problem. If you have trouble with that, I would just ask your teacher to go over it again. The last one on this page, it says a sequence is given by this recursive definition. So we're starting with 7, okay? To get to the next term, I am taking the last term, just gonna write down this definition to talk through it, and multiplying it by 2 to the n. So since we just started with a sub 1, next we have to find a sub 2, and we're heading towards a sub 4. So to get the second term, I take the first term and I multiply it by 2 to the second power. So that's going to be, the first term is 7. 7 times 4, 2 squared is 4, is 28. To get to the third term, I take the second term and I multiply it by 2 now to the third power. So that's 28 times 8, because 2 to the third is 8. So 28 times 8 is 224. And we just have one more, so a sub 4 equals the term that came before it times 2 to the 4th power this time. So that's 224 times 16. So that's 3,584.